Hey folks, in this video you're going to learn about the electric field. By the end of this video, you will be able to determine the electric field due to a point charge. So let's go ahead and start by talking about what the electric field does. So we use the electric field to measure the force a 1 coulomb positive test charge will feel at a given point in space. So on the left side of my page here, I have the electric field equation for a single point charge. So in this equation, K is equal to 9 times 10 to the 9th. Q is going to be the charge of our charged object. So charge on our object. And R is going to be the distance from the object at which we are measuring the electric field. And of course, this capital E here is going to represent our electric field, which is measured in newtons per coulomb. So, to go from my electric field to my electric force, all I have to do is multiply my electric field E by the charge on whatever I'm putting in my field. So once you know the electric field at any point in space, it is very, very easy to find the force on any charge placed at that point in that field. So let's go ahead and start with an example problem. And what I'm going to do in this problem is I'm going to find the electric field at point P due to my negative 6 coulomb charge. So I'm going to start by listing out my givens. So from this problem, I know that Q is negative 6 coulombs, and I know that R is 0.1 meters. And that's really all I need to solve for my unknown, which is, of course, our field at point P, or just E equals question mark. And as I mentioned earlier, the equation that we're going to use will be our electric field equation. So what I will say is I will say E is equal to KQ over R squared, which sets me up to go into my substitute and solve step. So sub and solve. So what I'm going to do is I'll go ahead and plug my givens into my equation. And what I will say is that E is equal to 9 times 10 to the 9th times negative 6 times, or divided, by 0.1 squared. And when I stick this in a calculator, I find that E is equal to negative 5.4 times 10 to the 12th newtons per coulomb. So my question for you guys, what does this negative sign mean? Well, when we're talking about electric field, it's important to remember that the electric field, E, is a vector quantity. So that negative charge is representing direction like it does for any other kind of vector. But things are a little bit more complicated with electric fields than they are with gravitational fields, because what we want to do with that sign is what we want to talk about when we talk about direction for an electric field. What we are talking about is the direction that a positive charge, so direction is where a positive charge would move if it was placed in the field. So to really accurately talk about our direction, we need to set up our frame of reference before solving the problem. So here I assumed a traditional frame of reference, which is, of course, this is our positive x direction to the right, and to the top of our page is going to be our positive y direction. So a test charge, a positive charge, placed in our field is going to move to the left or in the negative direction, which is why my electric field here has that negative sign. So takeaways. First of all, in this video, you learned that electric fields can be used to determine the force different charges will feel at a given point in space. Second, you learned that drawing field lines can help you determine the direction of an electric field.